Hello. Hello. Hello.
Yes, sir.
Are you ready to see the lecture?
Yes, sir.
Yes, sir.
Good. Very nice. So nice. Mute your audio.
Okay, sir.
Mute your audio. Okay. Today's lecture is on problems from NCERT. This lecture is for neet applicants. I'm starting from NCERT book. NCERT. In NCERT book that we have example 410. You can refer to that. If you have the book, you can refer to this example. The example is an insect. An insect is moving in a circle. It is moving in a circle. Actually, this is a groove, a space, a groove type space. I mean, a stream like. In this stream, it is very symmetrical. I have not shown it symmetrical, but it is symmetrical. An insect is moving in this space in a circle of radius or equal to 12 centimeters. And it makes some revolutions around in this groove. It's a space. Groove is a space. It makes some revolutions in this groove. It makes 7 revolutions in 100 seconds. What we have to find? Number one, that we have to find what is the angular speed. What is angular speed of the insect? Omega. Number second, we have to find linear speed. That is v. Number third, we have to find acceleration vector. Acceleration vector means you have to find its magnitude and direction. That is what he means by saying acceleration vector. These are the 3 things that we have to find. Okay? This is an example. It's a 410 example, 4 chapter 10th example. Now say, I have to find angular velocity. Angular velocity is equal to 2 pi by t. When it makes a revolution like this, 2 pi by t is the angular velocity. It is 2 pi, but what is t? T is time period. It makes 7 revolutions in 100 seconds. So can you tell me what is t? T will be given 100 seconds by 7. That is, time period is defined as the time for the insect to make 1 revolution in this circle. So it is 100 by 7. So that is 2 pi into 7 by 100. That is 14 pi by 100. That is 0.14 pi. That is the answer for the first part. Part second, what is linear speed? V. Linear speed V is, have a look, it is R, it is V, it is V, it is R omega, as you already know. R is 12 centimeters. 12 into 10 is power minus 2 makes it meters, and omega is equal to 0.14 pi. You can substitute the values, get the answer. And now the third is acceleration vector. As the speed is constant, there is no tangential acceleration. At is equal to 0 because the speed is constant. Tangential acceleration is the rate of change of speed. If the speed is constant, that means tangential acceleration is 0. So you have only centripetal acceleration, AC. And what is AC equal to? If you remember it, it's r omega square. Usually you know it is as v square by r, but that can be converted to this. You substitute r is 12 centimeters. You substitute r is 12 centimeters here. And you substitute omega square, that is 0.14 pi whole square. And if I find the value, that is 2.3 centimeter per second square. That is centripetal acceleration. It is the only acceleration, and the direction is towards the center, as there is no tangential acceleration. I want to remind you, if the speed is constant, then tangential acceleration is 0. If speed varies, only then there is tangential acceleration. If speed increases, then tangential acceleration in the forward direction, in the direction of velocity. If the speed decreases, then tangential acceleration is backward. Remember these things. Okay? Do you understand, boys?
Yes, sir.
Good. Number second question. And this question is, see here, it is NCRT 17th question, 417. Chapter 4, 17th question of NCRT. You can refer to this question. Refer to it later on. The question is 17th question. A stone is tied to the end of the string. It's a stone. It is tied to the end of the string and is moved in a circle like this. And it is 80 centimeters length. And it makes 14 revolutions in 25 seconds. It makes 14 revolutions in 25 seconds. What is the magnitude and direction of acceleration? What is the magnitude and direction of acceleration? This is a question that we have to do, that we have to solve. Just concentrate for a while. Just concentrate. Can you tell me directly what should be the formula for acceleration? Acceleration is towards the center, as you know. If it is moving in a circle and tangential speed is constant, then definitely the acceleration should be towards the center. And that acceleration is provided by the tension, of course. But what is that acceleration? If I write r omega square, am I right? Yes.
Yes, sir.
If I write r and omega is 2 pi by t whole square, am I right? Yes. It is r is equal to, it's 4 pi square by t square. It is r into 4 pi square. Pi square you should always write as 10. It is 10. And t square, what is t if it makes 14 revolutions in 25 seconds? Yes. What is t? T is time period, yani ki time taken to complete one revolution. That is 25 by 14. That is t, square of it. Now what is r? That's 80 centimeters. I make it into meters by multiplying 10 to the power minus 2 into 4. This pi square should be written as 10 by 25 square multiplied by 14 goes up is 14 square. You substitute these values and get the answer. That's your job. This is your job to substitute these values and to get the answer. Let me repeat. Acceleration is or omega square. R is given to be 80 and omega is 2 pi by t as you know the formula. And square of it as 4 pi square by t square. It is R is 4 pi square 25 by 14 because it makes 14 revolutions in 25 seconds. You need to find the time period for one revolution. That is the time period 25 by 14, square of it, and then you get the answer. Okay, let me go to the third problem. Third is 18th. I mean, chapter 4, 18th. The same NCERT. Volume 1. For page 87. An aircraft executes a horizontal loop of radius 1 kilometer with a steady speed of 900 kilometer per hour. Compared to centripetal acceleration, the acceleration due to gravity. It is an aircraft in space. It moves in a circle of 1 kilometer radius. 1 kilometer radius. And it has a speed of 900 kilometers per hour. We have to find its acceleration. Acceleration is towards the center as it moves in a circle. That is what you know. Velocity, speed is constant, therefore there is no tangential acceleration. So the net acceleration will be towards the center because there's tangential acceleration is 0. Had there been any tangential acceleration, then the net acceleration would have been somewhere in between. अगर ये tangential acceleration भी होता और ये दोनों होते, सर्कल में मूव करता और ये स्पीड भी बढ़ जाता, तो दोनों acceleration होते, तो आपको acceleration बीच में कहीं मिल जाता. लेकिन यहाँ तो tangential acceleration 0 है, therefore the only acceleration that it has is towards the center, that is centripetal acceleration, and that is r omega square. You can use v square by r. Here it is better to use v square by r because v is given. It is 900 kilometer per hour whole square by r, that's 1 kilometer. 1 kilometer. It is 900 kilometer 900 kilometer per hour square because 1 kilometer will get cancelled. This should be the answer. But you can always make it into meter per second. That is 900 into 10 raised to power 3. It makes it meters by r square. That is 60 minutes into 60, that whole square, because r square. R is make into seconds. That is 60 into 60. 1 hour, 60 minutes is equal to 60 into 60 seconds. And you substitute these values and get the answer. That's your job, not my job. Just square, just make it square is 10 raised to power 2, then cancellation, and then finally find the answer. That's your job. Okay, let me go ahead. Question number Question number 19. This question is objective type. He says, read the following statement carefully. State with reasons if it is true or false. First statement is, the net acceleration of a particle in circular motion is always along the radius of the circle. The net acceleration of a particle moving in circular motion is always towards the center of the circle. Is it true?
False.
It should be false. Good. Now, I think that you understand now. Because when a particle moves in a circle, there may be centripetal acceleration, but sometimes there may be tangential acceleration, right? And when you find the resultant of these two, the net acceleration is like this. It may not be towards the center of the circle. Although centripetal acceleration is always towards the center. But in addition to this acceleration, there may be some tangential acceleration. And if you find the resultant of these two, to find the net acceleration, it may not be towards the center. So it is false. Number one. Number second, do you understand or should I repeat it again? In circular motion, there may be two accelerations towards the center and there may be tangential acceleration. And when you find the net acceleration, that net acceleration does not go towards the center of the circle. Therefore, this statement is false. And second statement, the velocity vector of a particle at a point, the velocity vector of a particle at a point is always along the tangent to the path, is always along the tangent to the path at that point. Just concentrate on this statement and say particle is moving like this, right? Here at this point, what's the velocity of the particle? It's always tangential to the path. Here it is always tangential to the path. Here it is always tangential to the path. So it's a correct statement. When a particle is moving, you understand that? Boys,
Yes.
when a particle moves physically on a particular path, it's a physical path. The velocity at any point is tangential to the path, right? So it's a correct statement. There's no problem with this statement. C. There is one more statement. The acceleration vector of a particle in uniform circular motion, the acceleration of a particle in uniform circular motion, averaged over one cycle, is a null vector. Do you agree with this statement? Do you agree with this statement?
Yes, sir.
Good. Now let me explain. It is correct. First of all, I should tell you that a particle moving in a circle, but speed is constant. This speed is constant. Therefore, there is no tangential acceleration, right? And acceleration is towards the center. Suppose AC, that is v squared by r. And when particle reaches here, acceleration is towards the center, that is v squared by r. Particle is here, acceleration towards the center, that is v squared by r. Particle is here, and acceleration towards the center. If you find average value of these accelerations, so you can add all the accelerations. You can add all the accelerations and find the resultant. Let me find the resultant of these four accelerations. Four. You can find a resultant of any number of accelerations. But let us take these four accelerations as the what you call as representative accelerations. So what is this acceleration? It is like this. V squared by r. I take this first. Now take this and add second acceleration to this first acceleration. This is acceleration first is, I take it here. This is acceleration second, I add it like this. I'm adding these two accelerations means tail of the second on the head of the first. Now this is third. Now this is third acceleration. That is this one. There is fourth, that is this. The vectors close up. The vectors close up. The resultant is 0, as you must know. So you must remember that average acceleration of a particle moving in a circle with uniform speed is 0. The average acceleration of a particle moving in uniform circular motion is 0. Please remember it. For everybody should remember this statement. Okay, and I have proved it. I have added these 4 vectors and they are closed up, and therefore resultant is 0. Okay, now see. Now let me go to 31, 431, 4th chapter, 31 question. What is the question? A particle starts from the origin at t is equal to, no, 31. It is the last question on circular motion. A cyclist is riding with a speed of 27 km per hour. A cyclist is moving on a straight road with velocity 27 km per hour. This is the velocity of a cyclist is moving on the straight road, and all of a sudden he sees a turn of radius. Suppose radius is given to be what? Of what radius? Radius 0.5 meters. Of radius, of radius 80 meters. He applies brakes because if he moves faster, he cannot negotiate this curve. He applies brakes. When he applies brakes, he will create a reverse force. And that reverse force creates an acceleration in the backward direction, that is 0.5 meter per second per second. What do you mean by that? Per second means he reduces velocity of 0.5 meters per second in 1 second. He reduces velocity at this rate, 0.5 meters per second velocity. He reduces this much of velocity in 1 second. That means backward retardation is, or acceleration is, 0.5 meter per second square. But he says 0.5 meter per second means he reduced velocity at this rate. That means this is the retardation in the backward direction, 0.5 meter per second square. You understand my point? The cyclist is moving in the forward direction. When he sees the curve here, he applies brakes. When he applies brakes, he reduces his velocity at this rate. We have to find what is acceleration here. Be careful, it is the tangential acceleration in the backward direction. And there is one more acceleration, that is AC here. His velocity is 27 km per second here. 27 km per hour, per hour. And we have to find the net acceleration. Can't you find that? It is so simple. See here. We will find AC. We know tangential acceleration AT. And therefore, we can find the net acceleration. What is AC? That is V square by R. That is V square is 27 km per hour. That is V is equal to 27 multiplied by 5 by 18. Right? And you just solve this. It is V is equal to 15 by 2. That is 7.5 meter per second. It is 7.5 meter per second whole square by r, that is 80. You can find what is this AC. Now what is 80? 80 is simply 0.5 meter per second square. He says he reduces the velocity at this rate. Therefore, the backward acceleration, backward retardation, when he applies these brakes, he creates a backward acceleration. This, so that when he slows down, he can negotiate the curve successfully, right? So now you have two accelerations. What is the net acceleration? What is the net acceleration? A net is equal to root of AC square plus AT square. You can find out this. You have this. You can just substitute the values and get the answer. Now, what is theta? It makes angle with the maybe horizontal, maybe this vertical. Okay, let me find the velocity with the horizontal direction. So, what is theta? Tan inverse. What should I write? This perpendicular. And this is the base. जिसके साथ एंगल बनना है वो डिनोमिनेटर में आएगा ना वो पैरामीटर. So what is it? Is AC by what 80. Tan theta is equal to this vector by this vector. This component is AC and this component is AT. So AC. So you can solve this question by this method. Please इसको कॉपी कीजिए और कीजिए का सॉल्व कीजिए, अपनी जगह कीजिए सॉल्व. सिर्फ ये वैल्यूज आप डिटरमाइन कीजिए. It is your job, because if I start doing it, I have to use calculator. So you do it at your own places. Okay. Now these were the questions from NCERT. I have solved all questions from NCERT related to circular motion. Right? Now let me go to H.C. Verma. Again for NEET people. Again for NEET students. Okay. Chili. Good. Very nice. Let me pick up the book, this H.C. Verma. Okay, this is the book here. Hello, boss. Aur kis bakare pad phone kare. Okay. Chaliye. Why you write on the board? Remove this from the board, please. Remove it. H.C. Verma, page 114. Volume 1. Question number 1, let me start. The very first question I am going to start. There are some questions which are simple. Let us do all the questions, simple, complicated, so that you have a lot of practice with the questions. Question is, find the acceleration of the moon. We have to find the acceleration of the moon. It is moon, it is earth, and the moon is revolving around the earth. And what he gives time period of the moon, that is 27 point, how many days? 27.3 days. Time period of the moon around the earth. And he gives this distance also. This distance also he gives, that is r equal to, how much is the distance? 3.8. Yeah, good. Possibly you have the book with you.
Yes, sir.
Good, that's very nice. It is seriousness of the student. That's what I like the most. You must be very serious about things. You must have ICRMA with you. You must have NCRT book with you.
Yes, sir.
Then we can do things very patiently and try to cooperate. You see, there are 7 students now. There is no noise, but somebody has written on the board that irritates me a lot. Please remove this. Remove this yellow patch on my board. Do you also see the yellow patch?
Yes, sir.
Yes, sir.
This should be removed. This should be removed. Okay. Now he wants us to find acceleration. Now see, I will find the acceleration, but he does not give the acceleration due to gravity. He does not give the force. He does not give the masses. He gives only these 2 parameters. So see what I will do. Acceleration is simply centripetal acceleration because it moves in a circle.
Yes.
Speed is constant, right? So acceleration is r omega square. It is r into 2 pi by t whole square, right? It is r is 3.85 into 10 raised to power 5 kilometers into 10 raised to power 3 makes meters into 4 pi square by t square. T is 27.3 days. That is 24 hours. That is 60 minutes. That's again 60, and you have to square it. No answer. I will repeat. So it's r 2 pi t whole square is r. It is 4 pi square divided by t square. But what is t? T is time period. That is 27.3 days. But you have to convert days into seconds. It's a big thing to do, but it is the problem solved. It's all finished. Okay. Question number 2 from the same ICWAM. I will give you some assignment also today. Again, the same page 144. Okay. Question is, find the acceleration of a particle placed on the surface of the Earth at the equator due to the Earth's rotation. Diameter of the Earth is given to be 12800 kilometers and takes 24 hours to complete one revolution about the axis. See, it is Earth. And it, oh sorry, बहुत ही बुरा हो रहा है ये, नहीं आता है मुझे ये अच्छी तरह से बनाना. I should use this. अब बना ठीक. This is Earth. And it rotates like this. It makes one revolution in 24 hours. Here it's an object on the equator of mass m, let me suppose. When the Earth rotates, and this object on the equator also moves in a circle.
Yes, sir.
Right? It moves in a circle of radius this. He asks us what is its acceleration toward the center. The acceleration is simply what? R omega square. Isn't that?
Yes.
Because it also moves at the equator. When the Earth rotates, the object rotates with it in a circle of radius r. If the object would have been here, it would rotate in this circle, in a little circle. But here it rotates in a big circle, equatorial plane, right? So acceleration, centripetal acceleration is equal to r. It is 2 pi by t whole square. It is r 4 pi square by t square. R is given radius of the Earth.
12800.
Whatever he gives.
Yes, sir.
Time period is 24 hours.
Yes, sir.
If you substitute these values, you can get the answer. But pi square you substitute as 10. Huh?
Yes, sir.
So it is all done. No problem. Again, I will explain. An object at the equator, when the Earth rotates about its own axis, the object on the equator moves in a circle in the equatorial plane. And the radius in which it moves is or the radius of the Earth. And you use this formula and get the answer, because it is the formula you use for the centripetal acceleration. You may ask me, why don't we use v square by r formula? When omega is directly given, why should you use this v formula? there is no need to use this V formula if omega is directly given, or omega can be calculated very easily. Question number third. Okay. A particle moves in a circle of radius 1 centimeter at a speed given by v is equal to 2t, where v is the velocity in centimeters per second. T is, find the radial acceleration of the particle at t is equal to 1 second. Find the tangential acceleration. Find the magnitude. See here, a particle is moving in a circle like this, and it is speed. Its speed is equal to 2t, right? That means its speed changes with time, right?
Yes, sir.
Its speed changes with
Time.
time. If speed changes with time, is there tangential acceleration?
Yes, sir.
Good, very nice. How much is that tangential acceleration? dv by dt, rate of change of speed, that's 2. So tangential acceleration you got centimeter per second square. Okay, now what is the question he asks us? He asks us the question, find the radial acceleration of the particle. First I will answer the second question. Find tangential acceleration after 1 second. This is the second question, isn't that? It is the B part of this. Find the tangential acceleration at t is equal to 1 second. What is the answer?
2.
Answer is 2. Why? Answer is 2? Because tangential acceleration is constant. It's the speed which varies, but tangential acceleration is constant. So it is the same after 1 second, after 2 seconds, the same as this value. Now I will give the answer to the first, radial acceleration. I must tell you, it is now change of literature, it's change of this terminology. It is the same as centripetal acceleration. Radial means along the radius vector, right?
Yes,
along this radius. It is the same as what? Centripetal acceleration. That is, what is that? Good. Can you tell me? It's r omega square. Isn't that?
Yes.
So centripetal acceleration is equal to, okay, even v square by r. That is also the formula. What is v after 1 second?
2.
That's good. V after 1 second is 2. So it is 2 square by r. What is r should be given?
1 centimeter.
1 centimeter, good. 1 centimeter. So go 4 centimeter per second square, because everything is in centimeters. Now he says, find the magnitude of the acceleration, net acceleration.
Net.
Root of 4 square,
Yes.
plus
2 square.
2 square. That is root of 16 plus 4, that is root 20. You can find the answer now. Do you understand these basic concepts now?
Yes, sir.
I think you now begin to understand the basics of circular motion. It will help you in other topics also. If you have a good hold on circular motion and do good physics here in the circular motion, it can be used at so many places. Physics is something where if you have a set of equations, if you have a set of concepts clear in one field, you can apply it verbatim in other fields also. Okay. Now let me go to question number, which one? Fourth question. A scooter weighing 150 kg together with its rider moving at 36 km per hour to take a turn of radius 30 centimeters. What horizontal force on the scooter is needed to make the turn possible? A scooter, a person on a scooter is moving in wants to negotiate a turn of radius. What's the radius of that turn? 30 meters. 30 meters. 30 meters. And his weight is, the person and the scooter weighs 150 kg. It is mass basically, right? How much horizontal force is needed towards the center? That's the question. How much horizontal force is needed towards the center so that he negotiates this curve successfully? There must be force towards the center. Otherwise, he cannot move in a curve. Then he will move in a straight line. If no force applied, he will move in a straight line. और उस रास्ते से कोई path road नहीं होगा. He will skid off. How much force you need in the horizontal direction? In this direction? Yes, towards the center.
mv square by r.
Good. So what is wrong in substituting the values? What is the speed? किस स्पीड से जा रहा है ये स्कूटर वाला? 36. हाँ. Yes, speed is equal to 36 km/h. So it is 36 by 5 by 18 meters per second. That is 10 meter per second. Isn't that?
Yes, sir.
So you substituted 10 square here, and R is 30. It is your job to find the answer in newtons. Right? Is that good?
Yes, sir.
Okay. Fifth question. The horizontal force needed in the turn press is supplied. Suppose it is related to fourth question. He says if the horizontal force is provided by the normal reaction, what should be the proper banking angle? What is the proper banking angle? मतलब अगर ये रोड हॉरिजॉन्टल नहीं है, कुछ ऐसे है ये रोड, कितना ये थीटा होना चाहिए ताकि ये स्कूटर वाला जो है इसको यहां से फोर्स मिले उतना ही जितना हमें जरूरत है. वही फोर्स जो अभी हमको मिला वो अब हॉरिजॉन्टल फोर्स मिलना चाहिए हमें किसी सूरत से, वो बैंकिंग एंगल से मिलना चाहिए. तो कितना बैंकिंग एंगल होना चाहिए ताकि हमें ये फोर्स मिले? याद करो जब मैंने आपको बताया था tan theta is equal to v square by rg. याद है अभी?
Yes, sir.
कि फिर से यहां निकाल कर देता हूं, फिर से निकाल कर दे दूं इन ए मोमेंट. क्या आप इसको आपने याद रखा है? हेलो,
याद है.
चलो ठीक है. tan theta is equal to what is v square? That is tan square by what is r? What was r? Radius. What was the radius of the turn? 30 meters. G is 10. So it is 100 by 30 into 10. These two zeros cancel off, 1 by 3. Theta is equal to tan inverse 1 by 3. That is your answer. Directly substitute the values. So the centripetal force that we need is not provided by anything else except banking angle. The road is banked, it is raised from one side so that you just get the required force to move a body in a circle like this. इस circle में इसको move करने के लिए. Okay? अच्छा, okay. Now sixth question. Sixth question is even same previous question related to force. If there is no banking, what should be the frictional coefficient mu between the road and the bicycle? Between the road.
No, sir. Question number 6.
6 है.
6 वो है. A park has a radius of 10 meters.
Park has a radius of 10 meters. वो हो गया फिर खत्म वो question. चलिए ठीक है. Okay, good. That's very right. You have given me the indication. Yes. It's only possible when you have a book with you. चलिए ठीक है. Okay. Sixth question. Sixth question. A park has a radius of 10 meters. If a vehicle goes around in an average speed of 80, what should be the proper angle of banking? Again, we have to find the angle of banking. अगर एक पार्क है, हमें व्हीकल को मूव कराना है पार्क में, इस ये रोड है, दिस इज द रोड, outwards, not this way, it is outward road, it is something like this. ये रोड है, ऐसे रोड है, तो ये क्या एंगल होना चाहिए, बैंकिंग एंगल, so that the vehicle has to move in a radius of what, 10 meters with a velocity of 18 kilometers per hour. That is 18 multiplied 5 by 18, that is 5 meter per second. It is not a big deal. Theta is equal to tan inverse v square by rg. जैसे आपने भी tan theta is equal to v square by rg का कर दिया, तो theta निकाला जा सकता है. Just substitute the values. Theta is equal to tan inverse, tan square go 100, v 5 square 5 into 5, r means 10, g means again 10, 4. So theta is equal to tan inverse 1 by 4. Is that good? इस पर इस vehicle को चलना है of this radius, so that banking angle will give something like this. Somebody is here, this is mg, this is normal reaction n, this is theta again, this mg will go into two components, mg cos theta, this is normal reaction, this is normal reaction, this is theta, this is n cos theta, and this is n sin theta, and I have already told you how to do things, right? लेकिन हमने डायरेक्टली इस फॉर्मूला यूज करके ये कर दिया है. सो ये तो एक ही बात दिखाना होता है जो मैंने आपको दिखाया. ओके, नाउ क्वेश्चन नंबर
7.
Seventh question. If a road of the previous problem, हाँ तो ये मैं शायद मैंने इसको वहां लिया था. Seventh, if the road of the previous problem is not banking, so what should be the friction coefficient between the road, scooter and the scooter and the road? What should be the bank? What should be the coefficient of friction? I mean, when the person moves in a circle and there's no banking, right? So who will provide him the force, centripetal force towards the center to move it with a speed of 5 meters per second in a radius of r is equal to how much?
10 meters.
10 meters. Who will provide that force? Imagine yourself moving in a circle and there's no banking. तो रोड जो फ्रिक्शन होता है रोड और स्कूटर के दरमियान, that provides this. After all, in circular arcs, if there is no banking, you don't fall off. You don't fall off because there's a friction between the road and your scooter, and that friction provides the required centripetal force towards the center. So how much is the friction force needed? mv square by r, right? Who provides? Who?
Friction.
Okay, that's mu mg, maximum friction force. This gets cancelled, and mu is equal to v square by rg. That is v square is 25 divided by r is 10, g is 10, that's 1 by 4. Mu is equal to 1 by 4. That should be the answer. 0.5. Is that right? Okay. Now question number 8. Question number 8. Eighth question. See, eighth question. A circular road of radius 50 meters has an angle of banking equal to 30. At what speed should the vehicle go on this road so that friction is not used? A vehicle goes on a road and it has a turn of radius, it has a turn of radius 50 meters, and banking angle theta is equal to 30 degrees. What should be the speed so that it negotiates this curve of this radius with a banking of 30 degrees? एक खास स्पीड होना चाहिए ताकि वो इस कर्व को निगोशिएट कर सके. अगर उस स्पीड से ज्यादा होगा समझो you need more centripetal force and this banking cannot provide that force and it will stick it off or it will move in a radius of big, it will move in a path of bigger radius और वहां से रास्ता होगा नहीं, it will stick it off. I'll again tell you what should be the velocity that it should negotiate the curve for this banking. If your velocity is more than that value, then it can move in a bigger circle जहां से रास्ता नहीं होगा and it will stick it off. So what should be the speed so that it can negotiate this banking? I will tell you. Tan theta is equal to v square by rg, right? That's the formula that you know. V square is equal to rg tan theta and v equal to root of rg tan theta. If your speed is greater than this, you will stick it off. If your speed is less than this, then it's all right, no problem. But greater than this, you can stick it off. Greater than this is greater than r is greater, means you will move in a circle of greater radius, more than 50. So it will be root of, it is 50 into 10 into 10 30, that's 1 by root 3. You can substitute the values and get the answer. Now tomorrow I want that you try to solve the questions from in AC Verma from 9th to up to 22. It is assignment, your assignment. And tomorrow again NCERT, again AC Verma I will solve, and AC Verma I will solve from 22 onwards. Maybe if you have not been able to solve any question from 9 to 20, I will also solve those questions also. I will help in solving those questions, but you have to try from 90 to 22. And from 22 onwards, I will solve, but I will also help in solving these questions. And that will give you a lot of practice. But now what I fear the most, you will not do anything by yourself. That is I fear the most. If you try to do these questions from here to here yourself, and tomorrow when I give you the additional lecture, you will learn many things. I am very sure about it. It was the 4th lecture.
Sir, question है.
बताइए.
SC Verma page number 112.
Okay. SC Verma
112 page number.
SC Verma page number
112.
112. Question number?
Oh, object to first का question number 5.
112. Question number 5. Question number 5. हाँ ठीक है. क्या है question? A particle of mass and circular motion vary with the frame of. हाँ ये question number 5 जो है ना बेटे, हाँ ये centrifugal force पर है कि नहीं?
Yes sir.
देखते मुझे पता चला, ठीक?
Yes.
When I complete circular motion, then I will deliver a lecture on the centrifugal force, and possibly after then you can solve the question yourself, right?
Yes sir. Or question number 3.
Let me deliver this. First of all, let me deliver a lecture on centrifugal force and pseudo forces. उसमें सेंट्रीफ्यूगल फोर्स भी आएगा, वो मैं आपको बताता हूं. तब जाकर ये क्वेश्चन आप खुद भी करोगे या खुद नहीं करोगे तो फिर मैं दिखाऊंगा. और कौन सा क्वेश्चन?
3. Question number 3.
क्वेश्चन नंबर 3. हाँ क्वेश्चन नंबर 3 इसने कुछ दिया है, कुछ ऐसे कुछ किया है, फिर ऐसे कुछ किया, ठीक? इसने यहाँ पर पॉइंट ए रखा और यहाँ पर पॉइंट बी. तो क्वेश्चन क्या है? A car moving at a constant speed on the road shown in this, the normal reaction caused by the road on the car is Na. यहाँ normal reaction Na है और यहाँ normal reaction Nb है शायद. Okay. तो the normal force by the road on the car when it is with the point is, हमें देखना है कि इनके दरमियान क्या रिलेशन है. स्पीड तो सेम है ना v.
Yes sir.
है कि नहीं?
Yes.
स्पीड यहाँ भी सेम है, तो नॉर्मल रिएक्शन ऊपर की ओर होगा यहाँ
Yes.
एन ये क्योंकि कार तो ऐसे चल रहा है ना,
Yes. Yes.
यहाँ भी कार ऐसे चल रहा, नॉर्मल रिएक्शन ऊपर की ओर है, एन बी। ठीक,
ठीक।
गुड गुड, देखो मैं समझाता। ठीक है बेटे,
Yes sir.
ये एन ए है, ये एन बी। अच्छा, तो नीचे वाला कौन सा फोर्स है?
mg.
एम जी, और नीचे वाला फोर्स?
mg.
दोनों का मास भी सेम है ना शायद?
ये सिंगल कार है।
ये तो इट इज द सेम कार, यस दैट्स राइट। ओके बेटे, हैव अ लुक, बताइए इन विच डायरेक्शन यू नीड द सेंट्रीपिटल फोर्स?
Downward.
गुड, हाउ मच? mv स्क्वायर बाय
r
इज इक्वल टू?
mg minus na.
गुड, वेरी नाइस। अच्छा, मगर यहाँ रेडियस r1 रखो, हाँ, क्योंकि ये शार्पर है, ये वाइडर कर्व है, तो इट इज mv स्क्वायर बाय
r2
mg माइनस nb, राइट? तो यहाँ na किसके बराबर है? mg माइनस mv स्क्वायर बाय r1, ठीक? और यहाँ nb किसके बराबर है? mg माइनस mv स्क्वायर बाय r2। अब यहाँ का रेडियस ज्यादा है कि यहाँ का रेडियस ज्यादा है? यहाँ का ज्यादा है।
ज्यादा है सर।
अगर ये ज्यादा है तो ये कम हो गया।
ठीक।
अगर ये कम हो गया तो mg माइनस लेस इज मोर, सो nb इज ग्रेटर देन na, दैट्स राइट। हो गया काम?
यस।
फिर से बताऊंगा, यहाँ का रेडियस ज्यादा है, ये रेडियस ज्यादा है तो ये कम हो गया। अगर ये लेस हो गया तो आपने mg को सब्ट्रैक्ट लेस किया तो ये ग्रेट हो गया ना।
ग्रेटर हो गया।
तो इसी पर कंसंट्रेट करना है, तो सीधे na, दैट इज द आंसर। ओके,
यस।
लेट मी स्टॉप द मीटिंग नाउ।